Okay, so today we're going to start section 2. We're actually going to spend 3 days on section 2. You're going to have a quiz on this a week from tomorrow. So next Wednesday, a quiz on section 5.2, but again, we're going to split it up over 3 days. So today we're going to talk about the 6 different trig functions. So we did this last year in geometry. We did find sine, cosine, tangent, cosecant, secant, and cotangent, but we memorized it first. Some of you might have learned an acronym called Sohcahtoa. Now, at the beginning, you could probably use that where so is for sine and its opposite over hypotenuse. However, we're going to be filling in our trig values using x, y, and r. So let me go ahead and draw you a right triangle just to give you an idea of what these are going to look like. So if I draw a right triangle, and I'm going to be using the Greek symbol theta for my angle. So in relation to theta, we can see that the side that's opposite to theta would be over here. The side across from the hypotenuse, or from the right angle, is the hypotenuse. And then the side that's right next to theta is the adjacent. This is how we learned it last year. What we're going to see this year is the side that's opposite is going to be the y value. The adjacent is going to be your x. And the hypotenuse is going to be the r. And the way that we find the value of r is we're going to do Pythagorean Theorem. So what we're going to do is this formula up here where r is equal to x squared plus y squared. You're going to get your x and your y from an ordered pair. So if you recall, when you're given an ordered pair, the first number you see in the ordered pair is the x value. The second number in the ordered pair is the y. So when we graph these in a coordinate plane, they're going to give us a point that is going to be on the terminal side of our angle. So this would have been our initial side. And then if we were to draw this angle, which is theta, where it ends up, this is going to be our terminal side. And this ordered pair that they're going to give us is going to be a point on that terminal side. And the r value is going to be the distance from 0, 0 to that point. The r value is always going to be positive. Now, this is an example of an ordered pair that's up here in the first quadrant. Remember that the ordered pairs in quadrant 1 are always going to be positive, positive. Because both the x and the y values are going to be positive numbers, all 6 of my trig values are going to be positive. So all 6 ratios that I write are going to be positive in quadrant 1. When I go to write and I try to graph an ordered pair that's going to be located in quadrant 2 over here, remember, the ordered pairs in quadrant 2 are going to be a negative x but a positive y. Because over here, this is the negative side, but then your y values are going to be positive. So any one of these ratios up here that have an x in them, they're going to be negative. So bottom line, out of the 6 that we see up there, the 2 that are going to be positive in quadrant 2, they're going to be the sine and its reciprocal, which is cosecant. So let's come back up here before I do any more. So these are the 6 trig ratios that you need to memorize. Sine is y over r. Cosecant is its reciprocal. You flip the fraction, and now it's r over y. Then cosine is x over r, and its reciprocal is secant, and it's r over x. And then tangent, you're going to find it by putting y over x. And then cotangent, flip it, x over y. This is how we're going to come up with our 6 values for our trig functions. You'll be given the x and the y. You find the r by doing Pythagorean Theorem, and then just plug it in. So it'll be a good idea to memorize these. Now, luckily for you, you guys get to have a piece of paper with notes on them, so you can have all of these written down. Now, however, if you see this on a standardized test, they're not going to give you these trig values. You need to memorize them. So maybe come up with an idea or a way to memorize. Maybe if you're not sure which one, sine or cosine, gets x or y, maybe you can think about it alphabetically. So just like you're thinking about the order pair, it goes into the order pair alphabetically. I could also think of the words sine and cosine being alphabetical. Cosine, the c in cosine comes first, and then sine. So c gets x, and s gets y, if you think about it alphabetically. So remember, cosine is x over r, and sine is y over r. So whatever little trick will help you when you go to take the SAT or a PSAT. But as far as this year, luckily for you, you can have these written down. But it'll be a good idea if you can find a way to make it a more permanent memory. All right, let's go back and look at our different quadrants again. So now we're talking about down here. So remember, this is quadrant 1, this was 2, this is 3, and this is 4. Now we're in quadrant 3, where both numbers are negatives. So the only 2 out of the 6 trig functions that are going to be positive here are going to be tangent and cotangent. Because if you think about it, look at it up here. If I have a negative x and a negative y, negative divided by a negative makes this tangent become positive. So that's why in quadrant 3, tangent and cotangent are going to be positive. And then the last quadrant, quadrant 4, your order pairs are positive, negative. So whichever one has a y in it, that one would be negative, the others would be positive. So the ones that are positive here are going to be cosine and its reciprocal, which is secant. These will be the positives, and the other 4 will be negative. Now I've got a little acronym to help you. And that acronym, so again, if I draw my coordinate plane, quadrant 1, quadrant 2, 3, and 4, my little rhyme or my little saying is all students take calculus. Now, in quadrant 1, this all means all 6 are positive. The S in students in quadrant 2, that's going to stand for sine and its reciprocal. The T in take, that's going to stand for tangent and cotangent. Now, these are the only ones that are positive by looking at that first letter. And then the C in calculus, this is for cosine and its reciprocal. So in each of the other 3 quadrants, there's always only going to be 2 that are going to end up being positive. The other 4 will be negative. So a little trick to help you remember. Now, for tonight's homework, this little trick will help you confirm if you've set up the ratios appropriately. We will use this later on when we're trying to use identities to figure out which answer to keep. So let's try and see what you're going to be doing in tonight's homework. And so these next 2 examples are what you're doing tonight. Pretty good? All right. So let's give ourselves a visual. Let's figure out which quadrant this ordered pair is going to end up in. Obviously, if you look, it's positive 8 and positive 15. The quadrant that has both numbers being positive is quadrant 1. But let's graph it. So 8, 15, 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's way up here. Let's just say it's up here. So here is my ordered pair, 8, 15. My R value is the distance from 0, 0 to that point. Then I need to create my triangle. I always go back to the x-axis. So I'm going to drop this side down. Here was my initial side, and then the black line is my terminal side, because here is angle theta. So they created it this way. So you can see the blue line is 8 spaces long. The red line is 15 spaces high. I need to calculate the value of R. So the 8 is my x, and again you can see it right here in your ordered pair, x comma y. And then the 15 is the y. Now let's do the R. We're going to be using R is equal to x squared plus y squared, and we square root it. R is equal to 8 squared plus 15 squared, 64 plus 225 gives me 289. I have to square root it, and the length of R is 17. Now, for those of you who remember your triples from last year, this is actually a Pythagorean triple. So as soon as you saw that the two legs were 8 and 15, some of you are going to realize that that missing side for R is going to be a 17. If not, you quickly do this Pythagorean theorem here. So now I have everything I need. My x is 8, my y is 15, and my R is 17. I'm now going to take these three numbers and plug them in to these 6 trig ratios. So let's go ahead and do it. And this is what you're doing in tonight's homework. Sine of theta is equal to y over r. My y value is 15. My r value is 17. This is all we do. We're not using a calculator. We're just plugging in x, y, and r in the right spots. Now, I'm going to immediately do its reciprocal, which is cosecant. So the cosecant of theta is r over y. You flip it, so 17 over 15. The next one I'm going to do is cosine. Cosine is x over r. My x value is 8. R is 17. I'm going to do its reciprocal, which is secant. And I'm done. Well, let me tell you what it was. Let me erase that. Secant is r over x, which is 17 over 8. And lastly, I need to do tangent and cotangent. Tangent of theta is y over x. Y is 15, x is 8. And then cotangent, you flip it, x over y, 8 over 15. And this is what you're doing tonight with 4 questions. Yes?
If it's able to be simplified, we do simplify.
Correct. Yep. And if you end up with a radical in the denominator, you got to rationalize. Yes.
Can I move over there something unplugging my iPad?
Absolutely. All right, everybody good? Let's try the next one. Let me go ahead and let's graph it just to give ourselves a visual. So I'm graphing the ordered pair -3, -4. So 1, 2, 3, 1, 2, 3, 4, -3, -4 is here. So again, to make the triangle, this is your R from 0, 0 to the point. When we go to make the triangle, we make it go back to the x-axis, not to the y. So there's my triangle. Here's my angle theta. You're going to see that this is your x side, it's -3. This is -4. And now I need to find R. Again, I'm going to do Pythagorean Theorem. Now those of you who recognize this as a triple, you're going to see it's the 3, 4, 5 triangle, which is a common one. -3 squared plus -4 squared. 9 plus 16. R is equal to the square root of 25, which is 5. So now I have x equals -3, y equals -4, and r equals 5. I can now plug it in to what you're memorizing. So sine of theta, again, is y over r. So -4 over 5. I'm going to write its reciprocal right now, which is cosecant. Flip it upside down. 5 over -4. Cosine, that uses x. -3 over 5. Its reciprocal is secant. So 5 over -3. Next, I need to do tangent and cotangent. Tangent, y over x. Negative, negative simplifies the positive. Cotangent, flip it. -3 over -4, which also simplifies the positive 3 over 4. So remember the little trick. All students take calculus. We're in quadrant 3. The take stands for tangent. The only ones that should be positive in quadrant 3 are tangent and its reciprocal, which is what I found it to be. The other 4 are all negative fractions. All of these, if you would rather have just written the negative sign in front, it means the same thing. Just remember, if your numerator and your denominator are negative numbers, it simplifies to a positive fraction. This is what you're doing tonight in the homework. You're writing the 6 trig values. You'll be given an order pair. You will need to find the R value and then just plug in the 3 numbers wherever you need them. Now, this process is when your order pair is located in the quadrant. When your order pair is located on either the x or the y axis, these are called quadrant angles. And that's what we're going to see next. So for our quadrant angles, and this, for example, could be an angle that measures 0 degrees. It could be an angle that measures 90 degrees, which could look like this. And that could be your theta. Notice it's stopping here, and we would use this order pair when it's 90 degrees. If it were 180 degrees, which is another quadrant angle, it could come around here, it would stop here, and we would use this order pair as our x and our y. And then again, we could do also a 270. And we would come swirl all the way around to here using this order pair. And then also 360 which would be the full circle, which is the same as 0 degrees, which would be this one. Now I can also ask you to find negative degrees. So we could also go clockwise, and I could go this way and ask you for a negative 90-degree angle. So we can also do negative 90, negative 180, negative 270, and negative 360. We would just go clockwise instead of counterclockwise. So wherever you're stopping, that's the order pair you would use. So let's look at the 90. So the red one was the first one I drew, and it was using this order pair. So the x and the y that we're going to use for the 90-degree angle is going to be 0, 1. So x will be 0, y will be 1, and now I need to find my r value. Now, whenever you're using these order pairs, your r value is always going to be 1. But let me just show you using Pythagorean Theorem. If I did the 1 for the 90, r equals x squared plus y squared under the square root. So let's say I took the order pair for 90 degrees, which was the 0, 1, 0 squared plus 1 squared. 0 squared is 0, 1 squared is 1, 0 plus 1 is 1, square root of 1 is 1. It's not going to matter which one of these 4 ordered pairs that are on the axis you choose. The r value for the quadrant angles is always 1. And this is leading us into the unit circle. Yes?
Why is it not plus and minus?
For the r value? Because here it's already been rearranged, and I don't want, this is a distance and it's always positive. So I would throw away the negatives on this. Think of this as like a radius. This is actually the radius of this circle from here to here, and it would be the length of that side. And again, it's leading us into the unit circle. So let's go ahead and fill these in. Now that I know my x is 0, y is 1, r is 1, using that order pair, let me go ahead and fill in the same trig values using those same ratios. So again, sine is y over r. So y over r gives me 1 over 1. So sine of 90 is 1. Cosecant, this one's the reciprocal. So this one is r over y, 1 over 1, and it's 1. For cosine, this one uses x over r. This one is 0 over 1. When the zero's in the numerator, it simplifies to 0. However, when I flip it to its reciprocal, and it's r over x, now my zero's in the denominator. This is undefined, so this is no solution. So remember, when the zero's in the numerator, it simplifies to 0. When the numerator is in the denominator, it's undefined, so it's no solution. For tangent, we're doing y over x, 1 over 0. And again, this one is undefined. Over here, x over y. And this gives me 0 over 1, which simplifies to 0. When it wants me to do the 180, that order pair that I'm going to use is over here. It's the negative 1, 0. So x is negative 1, y is 0. And again, for all these quadrant angles, r is always going to be 1. Now that I've identified the values for x, y, and r, I now put them into the ratios. Sine is y over r. 0 over 1 simplifies to 0. Reciprocal, r over y. 1 over 0, undefined. Cosine uses x over r. X is -1, r is +1. So this simplifies to -1. Reciprocal, r over x, 1 over -1, simplifies to -1. Tangent, y over x, 0 over -1, simplifies to 0. Cotangent, x over y, -1 over 0, simplifies to undefined. Everybody good? All right, let's take a look at the reciprocal identities presented in a chart form. This is what we've been doing already. So remember that the reciprocal of sine is cosecant, or the reciprocal of cosine is secant, and then tangent, cotangent, and then same thing here. Don't get confused and think that the two S words go together and the two C words go together. You have to have sine with cosecant and cosine with secant. So they need an S and a C word together, and then a C and an S. So they both got to have one of each. So for example, if I said, given that sine of theta equals 4/5, and I ask you to find cosecant of theta, you can use the fact that you know that these are reciprocals, and then cosine of theta is just flip it 5 over 4. So know which ones are reciprocals to each other. Now, generally when, a lot of times we would give these identities and the Pythagorean identities on a formula sheet to our students when they would take the test and quiz for this class. However, no, for an SAT or a PSAT, they don't give you these. These aren't part of the formulas they give you. So you do need to understand and be able to memorize these for when you take those standardized tests and know how to use them. So let's try an example using these reciprocal identities. We'll do two more. So they want us to find cosine theta given secant theta. Well, if you realize that secant and cosine are reciprocals, to find cosine theta, all you need to do is flip that fraction upside down. Sine and cosecant are reciprocals as well. However, when I flip this upside down, I'm ending up with a radical in my denominator. In the homework tonight, it's going to tell you if you end up with a square root in the bottom, you need to rationalize. I need to fix this. In order to get rid of the radical, I need to rationalize by multiplying the numerator and the denominator by the square root of 6. I get 2 square root 6 over 6, and I can simplify this. Make this a 1, make this a 3. So final answer here is negative square root 6 over 3. My original ratio was negative, so is my answer. Its reciprocal will also be negative. You good? All right, more identities on the next slide. Now, this first box, this is here to sort of help you understand what your answer should look like. So the first one, the -1 is less than or equal to sine of theta, which is less than or equal to 1. Same for the cosine. All that's basically telling you is that your answer for sine of theta or cosine of theta needs to be a fraction. It could be a positive or a negative fraction. And let's think about it back in our geometry days. So for example, when you did sine of theta, remember if you use Sohcahtoa, sine was opposite over hypotenuse. And cosine was adjacent over hypotenuse. Remember, the hypotenuse is always the biggest side. So when you're putting the numbers in here, you're doing a smaller number over a bigger number. So this is why the answer for sine and cosine is always going to be a fraction. It might be a negative fraction, but it's got to be a number between -1 and +1. Whereas the second part here, the secant and the cosecant, remember this is reciprocal. So if sine and cosine are fractions, then their reciprocal functions are going to be integers. It's going to be a number greater than 1 or less than -1. Tangent, on the other hand, could be any number. That's why it's all real numbers. And same as cotangent. Because again, tangent, remember, if you think about TOA, it's opposite over adjacent. And your opposite could have been bigger than your adjacent or vice versa. So this is why it could be any number, not necessarily just a fraction or a number greater than 1. It's going to be any number. Then 2 more boxes for identities, Pythagorean identities and quotient identities. The Pythagorean identity, the first one is sine squared theta plus cosine squared theta equals 1. Tangent squared theta plus 1 equals secant squared theta. And then 1 plus cotangent squared theta equals cosecant squared theta. So when you're asked to write out these Pythagorean identities, do not forget to include theta. So if I ever ask you to list them and you told me the first one was just sine squared plus cosine squared equals 1, you would get that question wrong. You need to include the theta with each of the trig functions. The quotient identity there is tangent is equal to sine theta divided by cosine theta, and cotangent is cosine theta divided by sine theta. Notice in the Pythagorean identities, they all have squares, whereas this one does not. Now also, be able to manipulate these Pythagorean identities. And what I mean by that is if I give you this one, and I say, I want to know what just sine squared theta equals, I can subtract cosine squared theta from both sides. And I can manipulate and rearrange this one. And sine squared theta is equal to 1 minus cosine squared theta. So be able to rearrange these three into any format. Because what we're going to be doing with these is like a substitution. So like, for example, if I gave you a trig equation that had sine squared theta in it, and I needed to simplify things down, I could rearrange this identity so it looks like this, and then replace wherever I see this with this. So a lot of students memorize all the different versions of these three. Maybe what you might want to do is rearrange them all before you take a test or a quiz, so you have a quick, easy reference guide that have them all rearranged. I could do the same thing with the cosine. I could take sine squared theta plus cosine squared theta equals 1. And if I wanted to solve for cosine, I could move the sine over to the other side. So again, be able to recognize these identities in any form. And that would be what cosine squared theta would equal. So let's go ahead and try one more example, and then we'll stop here, and then I'll continue on with these notes tomorrow. So let's try our first example using these identities. Now, technically on this one, I could graph this, and I could figure out where it's located. Notice they're telling me it's in quadrant 3. So let's give ourselves a little visual here. So they're telling me that tangent of theta is equal to 4 over 3. So remember, tangent is y over x. So what this is telling me, it's 4 over 3. But in order to be in quadrant 3, I know the signs on my x and y need to be negative, negative. So this is actually a simplified fraction. So really probably what it was negative 4 over negative 3, and that's how it gets to be 4 over 3. Now, when it says to use Pythagorean identities, we're not doing this, but I just wanted to show you how it relates to what we've already done. So again, if I were to graph this, 1, 2, 3, 1, 2, 3, 4, I've already done this one. So it's the negative 3 and then positive and negative 4. So this would be my theta here. Negative 3, negative 4, and again my r value is 5. But we're not doing it that way. You could double check yourself and then just plug it in. Let's do it using the identities. If the instructions tell you to use identities and you do not do the problem using identities on the test or the quiz, you get it wrong. You must follow instructions. So let's try this one. They're giving me tangent. I need to find sine and cosine. I need to go back to the previous slide and figure out which Pythagorean identity has tangent in it. And that's going to be the first one, not the first one. It's going to be the middle one. So I'm going to be using tangent squared theta plus 1 equals secant squared theta. Now, if you think about why is she using that one? Well, I'm using it because number 1, my given was tangent. Number 2, they're asking me to find sine and cosine. The reciprocal to cosine is secant. So once I get my answer for secant, then I can flip it to its reciprocal. So let's replace what we know. We know that tangent of theta is equal to 4/3. So I'm going to replace this, and I'm going to square it. I now need to square 4 over 3, and it becomes 16 over 9. I'm going to change my whole number 1, and I'm going to make it 9 over 9. I'm going to take my problem and move it over here to the side. I'm going to go ahead and combine these two fractions, and I get 25 over 9 equals secant squared theta. Now, notice both of my answers I'm looking for do not have squares in them. So in order to find sine and cosine, I need to square root this. And now this gives me plus and minus 25 over 9 equals secant of theta. Now, here's where the all students take calculus comes into play. Remember, all students take calculus. They told me I'm in quadrant 3. The only 2 out of the 6 that are positive in quadrant 3 are tangent and cotangent. This tells me that for this red that I just solved, the only one I'm keeping is the negative. And actually I needed to square root that. Hold on, let me back up. This should have been plus and minus 5 over 3. The only one I'm keeping is negative 5 over 3 because I'm in quadrant 3. If they told me my order pair was in quadrant 1, I would have left the positive 5 over 3. Now I have secant, but I didn't want, they weren't asking me to find secant, they're asking me to find sine and cosine. So I can quickly find cosine because the reciprocal to secant is cosine. Flip it upside down, and cosine is negative 3/5. Still stays negative because remember we're in quadrant 3. Only thing positive is tangent and cotangent. Now I need to find sine. I got to go back and get another identity. I'm going to be doing sine squared theta plus cosine squared theta equals 1. Because I just found cosine, I can put that in here, and the thing they're asking me to find is sine. So now once I solve that, I've got my second answer. So I'm solving for sine squared theta. I'm going to replace cosine with what I just found, but I got to square it. Negative 3 over 5 squared is 9 over 25. I'm also going to change my whole number 1 into 25 over 25. Because now I need to subtract 9 over 25. Sine squared theta equals 16 over 25. I need to square root it. Sine of theta is equal to plus and minus 4 over 5. Again, I'm in quadrant 3, so the only one I'm keeping is negative 4/5. So there are your two answers to this problem using identities. Now again, if you would have gone back up to where I had graphed it initially, because they said it was in quadrant 3, I knew both of these numbers, my 4 and 3, were both negative. And again, if you just did the sine theta is going to be y over r, all you had to do was take this y and put it over r, and it goes right to the answer. Same thing for the cosine, x over r, negative 3 over 5. So it's a way you can confirm that all that work you did using identities gives you the same answer if you graph it. But again, it will be mandatory that you show all of the work and how you're plugging it into these identities. So this is where I'm going to stop now. Tomorrow I will continue on and do some more examples, enough to get you to do the next section of the homework. Again, tonight, remember your homework is not on WebAssign, it is that PDF, and there's only 4 questions on it. But again, you're writing the 6 trig values. So the 6 fractions. Don't make them decimals, leave them fractions.